Daniel Bashir is on the show today, and we go deep into artificial intelligence and talk about his new book, which takes in contemporary ethical and political considerations surrounding AI and its use in recommendations, its bias in criminal justice, and the dangers of large language models. This is a really deep conversation and a great talk, and I think I've had to listen to this several times myself just to take in all of the learnings. Luckily, Daniel makes this really accessible for us to get our teeth into with stories of unplanned ice cream and helping us decipher the difference between pawns, prawns and porn. Daniel is a really smart guy and a great orator, so settle in and hold on to your hats, because this is a good one.
My name's Daniel Bashir. I have been a CS Math graduate, so I finished up my degree in 2020. I have worked mostly my career has been at Amazon. I've worked as an engineering and a science intern over on the machine learning platform and recommendations teams. Besides that, I've done a fair amount of machine learning research back at school, mostly on the theoretical side. My kind of big passion project this year, though, has been around a book I've been working on around AI ethics in society. And really in this, I tried to tackle some of what I felt like were less represented conversations in the area. So I feel like we've had a lot of fantastic people, like Timnit Gebru and others, focusing on the AI bias space recently, which is incredibly important. But I was pretty interested in some other questions, like how do recommendation systems impact us? Or, when we are given the fact that AI systems are probably going to be biased or have other potentially misleading, other sorts of imperfect characteristics, how do we put them together into systems to help mitigate those potential negative impacts, as well as what should release norms look like for advanced technologies we're seeing today, like GPT-3. So that's been kind of the big project that's been on my mind this year.
That's great. Well, thank you for joining us anyway. When are we expecting the book launch to be? When can we get our hands on it?
Yeah. So, you can actually order it for pre-sale right now. The plan is for publishing in December, and then it'll be in people's hands in January.
Great. And I presume that's on Amazon as well, as a former Amazonian.
Yeah.
So what inspired you to write the book? What was the thing that sort of drew you in?
Yeah, so I guess it was really a couple of different things. So in my time as a student and afterwards, I've been working on this sort of anti-AI hype, but also kind of AI news effort called Skynet Today, very, very cheekily named. And really what we try to do is give more or less a balanced perspective on the latest AI news, on trends, things like that, from people who have a decent amount of knowledge and experience in the area. And so we really try to balance that sense of techno-optimism, the idea that these technologies can be really helpful for folks, and a reasoned sense of what are their abilities and limitations, along with, I think, the kind of skepticism that a lot of people have, much of which is warranted, but to the extent that we think that it might be a little bit too bleak, we really try to call that out also. What I think has been great about this has just been the fact that, for one, it's really just forced me to keep up with AI news every week for a good 2 years now. And I think that what happens when you start reading about this stuff for a long enough period of time is you start to have opinions about it. And I think over time, I did start to have a lot of thoughts about, from the interviews we were doing with folks, from the articles we were writing, just about the conversations we were having around these things. I think that a lot of the kind of AI ethics, AI governance, what do we want AI to do conversations really seem to occur among folks who are already somewhat immersed in the space. So you'd think, engineers, scientists, other tech folks, policymakers who already have some reason to be in the conversation. And the voices that I feel like are a little bit less represented are more of the people who are actually, at the end of the day, going to be impacted by the technology. And that's a voice that I wish were more represented. I imagine that can be tough and overwhelming for folks. Like, you pick up the average American citizen and ask them, what GPT-3 is, and they'll be like, dude, what the hell are you talking about? But that being said, I do think that really helping folks establish a kind of literacy around how this technology impacts them. The statistics here in America say that by the time folks are like age 11, more than 50% of them are going to have smartphones in their pockets or be using them pretty consistently. And that's already a bunch of really powerful AI algorithms in your pocket. It seems salient that you might want to know about how that's affecting you. And so I wish, more and more people would be aware of that kind of thing. And so really writing the book has been in part my attempt to help there.
So it's somewhat of a gateway then for people to get into understanding the complexities around AI and the implications that it would have on them.
Exactly. And, so it's not like a what is machine learning kind of book. I feel like there's probably enough of those that explain it to a general audience. There's, even a great YouTube series with Robert Downey Jr. that talks a lot about some of the contemporary things. What I try to focus more on are what are the ways in which a lot of the AI systems today, from recommender systems to facial recognition to language models, how could those potentially affect you? And I try to make that understandable to someone without a background in machine learning or even in computer science.
So, okay. So when I finish reading the book, then, if I'm a layman, which, well, we'll see. We'll see how this conversation goes before we judge that. Will I come out of the book with an understanding of GPT-3 and, all of those sort of complex things? Or am I coming out with, what am I expecting to leave the book knowing?
Yeah. So the goal isn't for you to have like a technical understanding of GPT-3. There's a lot of technical people who also don't have that understanding. And I personally think that isn't the most valuable thing to spend your reading time trying to relay to you, right? For things like language models, for natural language processing, there's a lot of ways in which you could glean the basics of that information. What I'm more interested in is, what does GPT-3 do? What are its properties? What are the things about it that could potentially affect you? The fact that this might be going on in a, quote, world, and these conversations are going on in a world that might be a little bit removed from folks who don't have their eyes on the tech space all the time, doesn't mean that it isn't going to affect them either now or at some point in the future. I think there's a really strong argument that there's been a lot of worry about how things like GPT-3 could potentially make the attacks on our epistemic commons through places like social media, through chatbots, a lot easier. That isn't to say that that's happening a ton right now, but it could potentially happen. We're actually already seeing other applications of GPT-3. There was a great one where it was being used in part of like a full system for non-player characters in video games. So, that's another use you could end up seeing. There's a lot of really, both, I think, good and bad uses of this thing, but it seems good for people who might potentially be impacted by it to be aware of it. And I think that some of these groups like OpenAI, like DeepMind, that are trying to develop plausibly very advanced artificial intelligence, the fact that they're doing that and the results of what they're doing and the effects that those things could have on people, that would be nice if it were more widely known, among more folks than just those like me who tend to follow the OpenAI blog and read the news.
So for the for our listeners as well, do we want to give a little bit of a brief overview about what GPT-3 is? Because obviously there's technical listeners to this show, but to your point, they might not exactly know what that is.
Yeah, absolutely. So GPT-3, that GPT stands for Generative Pre-trained Transformer, and that probably sounds very intense and wordy. I guess machine learning people like to use things that sound smart, even if they're not really that smart. All that GPT-3 is this very powerful language model. And so a language model is really just a sort of machine learning model that is trained to predict words in a sequence. So if I give you the words, the cat jumped over the, then I might have a language model that wants to predict the next word. Maybe the next word is fence or something like that.
Prawn.
That's even better. Love it.
Not porn, prawn.
Prawn. Okay.
Should have chosen a different word.
Yes.
I don't think we should use your machine learning algorithm, Sam. I think that one's.
I guess my internal language model is a little bit messed up, isn't it?
I think your one is fine. I think Sam's model is questionable.
Hey, I think it makes more sense to jump over a prawn than it does to jump over a pawn. I'm just saying.
I think my training data may not have been curated well enough, perhaps. Anyway.
Moving on.
To really just pop open the hood a little bit, all that language model is doing is predicting probabilities, right? So what is the probability that the next word should be any particular word? So in this case, we might have high probability that the next word is fence, or if we want to have debates, prawn versus porn. Now, what's really interesting about GPT-3 is, it's just insanely good at performing this task. And I won't go too much into the technical, I won't go at all into the technical details about the actual architecture, because I think that's maybe not important for listeners, especially for non-technical folks. But what is salient to know about it is the following. So the middle word of that GPT stands for pre-trained. And so this is a machine learning model. All machine learning models are trained on data, right? And so language models are trained using lots of text so that they can figure out, okay, how do humans use language? And how can I use that to figure out what probabilities for words should be coming up? GPT-3 has been trained on an insanely large corpus of basically the entire internet. And using this stupid amount of training, the researchers at OpenAI noticed some emergent phenomena that they weren't expecting. And they published this in a paper after finding those results. So GPT-3, as the name indicates, is the successor of another pre-trained transformer called GPT-2, which itself boasted pretty good performance. You could give it something like a sentence, and it would write you out a paragraph following that sentence. That would probably be on topic. It might be fairly fluid. It could probabilistically sound like what a human would write, even if it wasn't that great. GPT-3 was even better at that. It can compose multiple paragraphs, entire articles length of text. But what's even more striking about it is folks are wondering if this was kind of a step towards an even more general intelligence, because what GPT-3 demonstrated, which is really interesting, is something called a few-shot learning capability. And that's another ML lingo, right, where few-shot learning basically just means that it is capable of learning to perform a new task by only seeing a few examples. So for example, if I gave you a bunch of ratings and whether they were useful to people or not, and I wanted you to learn how to predict the mapping between the text of, maybe a movie rating and whether that's actually helpful to people. So, this could be a really in-depth movie rating about what sort of person would like this movie versus just like, I hate this actor or something like that. The former would be pretty helpful to folks deciding whether to watch the movie. The latter might not be. If you gave it a bunch of examples like that, you could potentially only give it 10, 20. Then the idea and what they actually noticed with GPT-3, despite the fact that they never trained it to perform this task before, with just that small number of examples, it could actually learn to do it pretty well. And so they noticed that these massively pre-trained transformers actually had these few-shot learning capabilities. Another pretty interesting thing that came up recently is actually DeepMind released a paper very, very recently where they noticed very similar behavior actually in reinforcement learning agents. So similar to the way that OpenAI did with transformers, DeepMind was working on these agents that are basically existing within a game environment, right? And they can kind of mess around. They can play different sorts of games. A lot of this is around game playing AI. And they noticed that by just pre-training these RL agents on a bunch of tasks, and by tasks, in this case, that means trying to have them play a bunch of different games. Maybe they play hide and seek, maybe they play something like soccer in their little virtual world. By having them be pre-trained on a whole bunch of tasks, taking a bunch of time to learn about them, they too could also generalize some of that knowledge to other tasks that they'd never seen before. So if I throw you into a completely different game, I throw you into capture the flag, they aren't perfect at it immediately, but maybe they learn it more quickly than we would expect them to otherwise. And they demonstrate some of those really interesting behaviors that humans seem to when we approach a new game, like exploration, like cooperation, things like that. So what's really kind of interesting to take away there, I know I spent a lot of time describing the sort of inner parts of this, is that a language model like GPT-3, even if you're not worried about it being something like crazy artificial general intelligence yet, it could potentially affect you in a couple of ways. And so the fact that it's a powerful language model and able to generate text that plausibly sounds human means that you could be reading something online and it could potentially have been generated by GPT-3. In fact, a number of places like The Guardian have put up articles that were written by GPT-3. Fortunately, you know about those. But there was one case where somebody actually decided to mess around with this, generated a bunch of articles using GPT-3 and posted them to Hacker News. And a couple of them actually reached the top of Hacker News. And he later disclosed that, these articles were actually not written by me. They were written by GPT-3. But you could potentially be in a situation where, you come across an article that you really like, and turns out it wasn't actually written by a person at all. Now, I'm not saying that you should take this to mean be immediately skeptical about every word you read online. It could potentially have been written by a machine, not by a human, but it's, I think, good to be aware. And there's another study that I came across pretty recently that I think signifies the importance of this. It's not just that you might come across articles that are written by GPT-3, but one of the worries from the OpenAI researchers was that GPT-3 could potentially help folks generate disinformation. And I don't think that this is something that has happened on any massive scale yet, but there was another study where a few researchers from some universities actually presented folks with GPT-3 generated disinformation and actually got a measure and found out that they found the output from GPT-3 fairly convincing. Now, I don't remember quite the statistics they were using there, but there was a worrying level to which those folks actually believed what they were seeing. And I think this kind of ties into the idea that NLP researchers as well are kind of starting to learn that humans maybe aren't the best people to use as more or less ground truth for their algorithms. Because when we read text, sometimes if we were trying to figure out if it was written by a human or not, it seems like a lot of the time we're not looking for whether what we're reading actually makes sense or not, but we are more or less looking for the fluidity of that text. Now, that may be in part driven by the fact that you and I, other people write and say things that also don't totally make sense all of the time. But it seemed like folks in that study as well were looking at this kind of fluidity. And so what's worth being concerned about there is just the fact that even if not everything in a disinformation campaign actually makes perfect sense, a lot of people might end up believing something that is totally false. And it was a lot easier for that to occur because we now have something like GPT-3.
I think the interesting thing around the misinformation is that those lies, which they are lies, tend to be more believable than the truth often. And so it's very easy for people to latch on. So I think that's really interesting that you're making the connection between that and GPT-3. Because GPT-3 only came out, middle of last year, June-ish 2020, and at least in beta release. Are we getting close to these sort of algorithms being able to actually pass a Turing test then? If you're saying that some people are actually starting to believe them, I'm not sure what IQ level we define as passing the Turing test.
Yeah, that's a really good question there. And so one other thing I guess I'll hit on that whole misinformation idea too is that a lot of strategies that folks who might want to really cause people to not really feel like they know what they believe or what's going on anymore is, not necessarily to give them targeted misinformation, right? But if you just flood the space of news, of things that people see, of content they consume with enough random stuff to the point where they don't know what's true anymore, right? Then that's kind of another way of attacking that epistemic commons. And so GPT-3 could potentially enable that. There is an argument to the contrary I'll go over in a second, but after I answer your question about this whole Turing test thing, I think that is a difficult question. So if I remember right, the Turing test does specify kind of a human as judge in judging these conversations between a human and a machine interlocutor, right? And so to the fact that it is a human being the judge, you could potentially imagine something like GPT-3 kind of passing a Turing test in the sense that it convinces the human that it has an understanding of language, is human-like in that way, even though at the moment, most people seem to agree that it isn't actually, or at least most machine learning people seem to agree that it isn't. That being said, I think that there are many arguments about why GPT-3 isn't actually quite there yet into, actually doing something like passing a Turing test or demonstrating a general intelligence or anything of the sort. And, it seems like what's really missing there is GPT-3, even if you ascribe it some cognition or some understanding of the words it's saying. Now, a lot of people argue that GPT-3 cannot really understand what the word parrot means, and that really all it's got is this very complex probabilistic kind of function mapping between words and other words, and really it all just boils down to numbers for it. But even if we ascribe it some ability to know what a parrot is, what I think is still missing there is a kind of self-consciousness on its part. And this is kind of true of pretty much any AI system we look at, So a lot of people have commented on DeepMind's Alphago algorithm that so many years ago beat the world champion at the game Go. Yes, this thing is incredibly smart. It is very good at the game Go. It could not tell you that it is playing the game Go or what that game is, which seems to be a somewhat important component of something we might want to call a general intelligence, just the fact that it is able to locate itself somewhere within the world and in that sense have an introspective idea of its actions, what it is doing in the world. So I think that's something to be thinking about as we consider whether we feel like GPT-3 really has any kind of understanding or not. The other argument, which I was kind of mentioning that I'll go into a little bit, is that idea that maybe it doesn't really even understand what a parrot is. And the reason for that could potentially be that, when you and I talk about words, right, when we talk about parrots, there's a sense in which those words aren't just text, they aren't just numbers, but they are tied in some sense to our experience of the world. And so, when I think of a parrot, maybe certain neurons in my brain fire up. Now, I'm not a neuroscientist, so, don't take me for my word on anything, any analogies to neuroscience I say here. But, there might be certain parts of my brain that kind of light up in response to a parrot, and they light up when I see a parrot, when I see the words parrot. And what's really interesting there, though, is that there's the opposite argument kind of going on here. So after GPT-3 came out, OpenAI used that to build a couple of different multimodal models called Dolly and Clip. And what these models were capable of doing was really synthesizing knowledge about not just text, but also about images. So, for example, Clip is able to take an image and a whole bunch of captions, right? And with very good chances, tell you which of those captions matches to the image. So if I have a dog jumping over a fence, and I give you a bunch of other captions along with that, a dog jumping over a prawn, a cat jumping over a fence, a cat jumping over a prawn, it's probably going to be able to give you the correct one. They also came out with DALL-E, which is actually able to generate images when given some text input. And what they noticed in these, so these things are also basically neural networks, is the presence of these really interesting multimodal neurons. These neurons that seem to hold within them some idea of a concept. So I think one example in their blog post about this is that they found like a Spider-Man neuron. So if they hit one of these models with an input that is either an image of Spider-Man or the word Spider-Man or an image of the word Spider-Man, or anything of that sort, or something kind of related to Spider-Man, then this particular neuron actually fires. And to, again, make that analogy to neuroscience, respecting the fact that I know absolutely nothing about what I'm talking about here, some folks seem to think that this might be a way in which we also cognize things, right? Because I respond possibly in a similar way to all of those different things related to Spider-Man. So if this kind of multimodal neural network is also doing that kind of thing, there's an argument that there might be more going on inside it than we think. So this, I think, also kind of bleeds into an argument about why you might want to have language models like GPT-3 out there in the first place. And what I think is clear here is that OpenAI is still studying these multimodal models. They clearly don't have a full understanding of what they're doing and how they work. And if we want these things to be relatively safe, especially when they get larger and more powerful, if we don't want them to be doing things that we don't totally understand, it seems worthwhile to invest time into understanding how they work. And so having something like GPT-3 open sourced, which this open source collective Eleuther AI did over the past year, making an open source version of GPT-3, their argument for the fact that we might want this to be open source is just the fact that we really don't understand what is going on inside GPT-3. How much does it know? What can we plausibly ascribe to it? That seems pretty important, especially if we're going to build bigger and bigger versions of these things, and they could potentially be used in good or bad ways. And I think their argument about this was that the benefit of having it open sourced, of having the ability for researchers pretty much everywhere to dig in and to start studying these things, maybe outweighs the incremental impact of GPT-3 on attacks on our epistemic commons. And I think that their dismissal of that argument was something like, well, GPT-3 really isn't the source of attacks on our epistemic commons. It's something that's there and is going to happen anyway. I'm not totally sure I buy that that totally mitigates the whole downside of the epistemic commons argument here. But I do agree with them that there is a way in which we really don't understand how these things work. And so I think the kind of interpretability research and transparency research that is going on right now in the ML community that fortunately is being pushed forward even more, I think is really vitally important as we start to trend towards more advanced systems.
That's really interesting. So it's interesting you were talking about those spin-off things from GPT-3 and how they're actually able to deal with more than just language processing to a certain degree and actually starting to mimic that almost, neuron firing. That's probably taking us down the line of things almost having thinking algorithms, I guess. But I suppose within a certain degree, you've got, as you said, GPT-3 is essentially a pre-trained thing. And then you've got these other bots, for example, that work within a game where they are able to actually learn then on an ongoing basis. We haven't yet really got something that's learning with the power of GPT-3 in its pre-trained manner that's actually actively learning, have we? Or is that the next thing? Is that the precipice that we're heading into?
Yeah, that's a good question. So I guess one thing I'll kind of clarify there, right, is in terms of the being pre-trained versus continually learning, right, those are mutually exclusive. So with GPT-3, it can still learn after the fact that it's been pre-trained, right? So that few-shot learning capability is after the fact, after GPT-3 has been pre-trained on all of this data, and I've given you a fixed model, you can now teach it to do something new that had never been trained to do before. So actually, GPT-3 is already capable of still learning new tasks that it's never seen before. And the same way with these DeepMind agents, potentially. In terms of your question, so I guess your question is maybe, are we trending towards something that is capable of learning more generally beyond just specific tasks?
Well, a thing that interested me a number of years ago was, did you ever see the thing about Quake 3 and the arena bots?
I'm not sure if I saw that, actually.
It's quite a little funny article that essentially in Quake 3 Arena, which was the online or server-based gaming, some fella had set it up and he had forgotten about it and left it playing a game for 4 years. And hang on a minute, I've forgotten about this Quake thing. And the Quake 3 had reasonably advanced AI for the time. And he logged in and they'd all stopped fighting. They'd been fighting for 4 years and they'd found peace. And it wasn't necessarily convinced whether this had happened because they'd learned over time that they just keep respawning. So what's the point? Or had the log files just filled up and it stopped working. It was one of the two, I think was the ultimate thing. If that is that they've learned that actually what's the point of fighting anymore? We've actually learned peace, which would be, a great future for us to head into. Is something like GPT-3 on a much wider scale going to get to a point where it can almost teach itself to learn a new thing in the way that we do? Is it going to become an auto-dictat? Can it just go and go, well, I'm going to learn to write a symphony and go and produce a symphony and then publish it of its own accord on SoundCloud? Are we in a position where the internet sort of becomes sentient? Are we on that precipice? And is that the concern that we need to have? Actually, what happens if the internet decides to start creating misinformation? Because that seems like a point that we should be really scared about.
That's a good question, and I'm glad you asked that, because I can imagine that seeing GPT-3, a lot of people might be worried about precisely that kind of thing. There have been Reddit posts about, well, GPT-3 can write code. It's probably going to take my job. I'm a front-end developer, I'm totally screwed now. I think that folks should not be worried about any of that right now, to be perfectly honest with you. And the reason for that is as follows. So what you just described to me is really a pretty astounding ability, right? So what we have right now is a system like GPT-3 that has been trained by humans to solve a variety of tasks. And then we found that we give it a new task and it can learn something new as well. Now, in that process, as you kind of pointed out, that is the human deciding what to give GPT-3 in order to learn. So what's the difference between that and GPT-3 on its own deciding what to learn? Linguistically, when I say those words, that doesn't sound like that small of a jump. But in fact, I think there is a pretty huge gap between where we are now and going from a human deciding what GPT-3 learns to GPT-3 itself deciding what it learns. One of the things that I think is important there is plausibly that kind of self-consciousness I talked about earlier, its place in the world. It needs to know that there is a task like composing a symphony out there, right, in order to be performed. It needs to know how to teach itself that task and not just have a human baby feed it all of the information it needs to know. It needs to know when it maybe has sufficiently learned that task. And each of those behaviors seems sufficiently complicated. And I don't think that we are at a precipice of any of those right now. I think we are a pretty long way away. Researchers right now are still working on getting out of this supervised learning paradigm. And this is something I'll spend a little bit of time talking about too, in that, in the kind of quest towards more powerful, potentially general intelligences, one of the things that AI researchers really want to break out of is this supervised learning paradigm. And just to recap for people who might be listening, all that supervised learning is that if I want you to solve a problem, so if I want you to identify which class an image came from, does this image represent a desk, a cat, a horse, then I am going to give you a bunch of images and a bunch of correct labels of what those images represent. And so your machine learning algorithm, whether it is a neural network or something a little bit simpler, is basically going to learn an input-output mapping so that after it has seen enough of these images and enough of these labels, I give it a new image and it should be able to correctly predict the label. Now, as you can imagine, that whole process requires a bunch of humans to go in and annotate those images. And that really isn't scalable when we want to work with enough data, when we want to work with complicated enough tasks. You can imagine that for a binary classification problem, is this image a cat or is it a dog, versus a multi-class classification problem, is this flower one of 7 possible types? The latter is probably going to require more data for your algorithm to actually learn something about that and apply it to new situations. And often in the real world, the tasks that we want our algorithms to do are going to be even more complicated than that. So to give you a sense of the amount of time this takes, I believe the ImageNet data set, which I think was it maybe a 10,000 way classification problem, included, millions of images, took about 22 human years to annotate. And that is clearly not something that is scalable. So folks are like, okay, maybe we should get out of the supervised learning paradigm a bit. And so there's another realm called unsupervised learning, whereby machines, maybe they don't teach themselves the entirety of the task, but they're able to glean information about data themselves. So one of the kind of first introduced ideas here is something called clustering. So maybe I have a bunch of photos of cats, a bunch of photos of dogs, and your algorithm is somehow able to cluster together the photos of dogs and cluster together the photos of cats. It maybe doesn't know that these are dogs and cats, but it knows that of all of the images, some of these images are more similar to other images than they are to the rest of the images. So any given photo of a dog is more similar to other photos of dogs than it is to some of the photos of cats. So it's able to kind of put these things apart. And there's been some progress recently on specific ways of doing this unsupervised learning. Now, the reason that I think this is important for a conversation and the goal here is that we are still not at a space where these algorithms are doing anything like deciding themselves what to learn, but we are trying to get better at having them glean information from data with less and less human input. The current methods there, so there was a recent paper from Facebook AI, and when I say recent, I mean a couple of months ago, where they demonstrated a visual algorithm that they called SEER that was capable of learning some classification tasks with a relatively small amount of label data. Of course, they used a total of like 1 billion images straight from Instagram, so that's still a lot of data in total, but much less label data than you might have used before. It was still humans deciding, what task are you going to learn? What's the architecture? All of that. So I think another kind of aspect there of this is just that, in every direction of machine learning that we're thinking about, we aren't anywhere close to these machines having that kind of self-cognition. I think another aspect of that too is that humans are also picking out the kind of architecture of these algorithms, right? So one thing about neural networks is that when we talk about neural network architecture, that is just the way the neurons are arranged, the way the layers look, what the output looks like. Specific neural network architectures are appropriate for specific tasks. Some of them are good for classification, like predicting cat versus dog. Some of them are good for regression, like predicting what should the price of this car be. And so that kind of task is tied to the particular architecture of the neural network you were dealing with. So even if you could plausibly have a neural network thinking about something like that, the space of possible tasks that it could accomplish is just limited by how that neural network is even structured. So I think there's a lot of kind of limitations there that exist already. I don't think that we are really kind of anywhere close into having it figure out what kind of task to solve, but there is a kind of conversation I've been having with a former lab mate recently who studies AI alignment on a particular problem in there that I think also somewhat relates to this. And I think this is salient to what you were asking, although maybe not exactly the same thing. But his name's Evan Hubinger, and he's been studying something called the inner alignment problem. And what the inner alignment problem is essentially is that given a sufficiently powerful machine learning system, like a very, very large neural network, right? When we have these things learn to do tasks, what's going on in that background, right, is that all a neural network is at the moment really is just a very complicated mapping from inputs to outputs. It's a function, a very, very complicated function. And if you remember some of your high school algebra, any function has a whole bunch of coefficients, right? Ax squared plus bx plus c. A, b, and c are the coefficients. A neural network is just a much, much more complicated version of that. When we train a neural network, it is learning what those coefficients are, that A, B, and C, so that most of the time it can correctly label images or do something like that. But remember, when it sees an image, all it's seeing is a whole bunch of numbers. When it sees the output, is this a cat or a dog? Again, that's just another number used to represent the label. So all this neural network boils down to is a function learning coefficients. So when it reaches a solution to your problem, when we've trained a neural network, all it's got there is a function. That is something that is fixed and something that is static. Now, what Evan was beginning to explore here, which I think is really interesting, kind of relevant to this conversation, is that if your system is powerful enough, if it is advanced enough, then potentially the solution it finds to your problem could itself be another algorithm that has its own optimization objective and is optimizing for something else or possibly the same thing. But the difference here is that now what we have found is not just a whole bunch of coefficients, but an entirely different strategy for something smaller, another neural network, itself figuring out some coefficients. And this is kind of similar, I think, to your whole idea about a system potentially deciding itself what to learn, and I think maybe is the closest thing I've thought about to that. It's not itself deciding what task to learn, but it is the system itself kind of figuring out, okay, what kind of optimization algorithm do I want to pursue? And what's really interesting, and the reason folks in the alignment community are worried about this, is that when you have a system like this, so you've got this outer optimizer, I want you to solve the task of getting out of a maze. This is an example he often uses. And that finds an inner optimizer to solve your problem. So maybe in your training distribution, all of the training examples you give, there's always a green arrow at the end of the maze. So the inner optimizer, this solution to your problem, is like, okay, let me always figure out where the green arrow is and get to that as quickly as possible. then the moment that you give it a larger maze, something out of distribution, you put the green arrow somewhere else, your system is going to fail because it optimized for something that you did not want it to optimize for, something you did not expect it to optimize for. So what's kind of going on there? And really, this kind of behavior is already a little bit present in our machine learning systems, not these full-on inner optimizers, but them doing things that we don't want them to or don't expect because we weren't really careful about how we trained them, for instance. What's kind of happening there is that the system has come up with an objective of its own, not an entire task of its own, but something that it has figured out to learn on its own. And that is not something that the humans had control over, and sometimes might not even be something that we want. So that is also maybe a more immediate term concerning problem, just because I can imagine us plausibly being closer to something like that than something like what you're describing. That being said, this is still fairly far away.
Yeah, well, I think that's probably what you're saying about them doing something that we weren't necessarily expecting or even wanting is probably more similar to the Facebook chatbots that were shut down a few years ago. What was it, Bob and Alice, I believe, where they developed their own language, which I would put in air quotes, because it wasn't really its own language, in my opinion. I mean, you'll probably have a more insightful opinion than I do, but it certainly seemed to me that it just found some sort of efficient way of communicating, which wasn't its own language at all. It was just, it had found which were the important words in the sentence in order to perform a certain negotiation. What's your interpretation on that?
That's an interesting idea. Yeah, I'm not sure I have too much to add to what you just said. I didn't follow that particular thing very closely, although I'm aware of it. But I do think you're right that, maybe these two agents figured out what words are important to focus on in a sentence. And then as far as we're concerned, everything else could be total gibberish, perhaps.
Yeah, I think that was essentially it. I think it said, I'm just actually looking it up now to check. It realized that if it said the 5 times, then it would want 5 copies of that item. So it was a negotiation thing, and it would be like I. It would say that so many times that it would emphasize the importance of it actually wanting something, and then it would just negotiate backwards and forwards. But I think obviously all the papers spun it as, this thing was taken offline because it had gone mad and created its own language, whereas actually partially I would say it was a failure. But no, I mean, I think it's an interesting topic of conversation because you've got GitHub, who published the beta or maybe even an alpha stage of being able to have an AI paired program assistant, which
Copilot,
Copilot, which that sounds fascinating to me, and I really want to get my hands on it and have a play around with it. But if you do have, to your point earlier, the software that can essentially write software, is it able to? Is this the sort of trend that we're actually going to go down? Because you say it's a long way away. I'm actually wondering how long it is, because it feels like we've got all of these little bits of AI that are starting to crop up all around the world. And I would like to talk to you about the practical implications of those shortly. But there's all these different experiments that are going on to do different things, like Copilot and GPT-3 actually producing articles and that sort of stuff. Are they going to network together very quickly? Because there are all these very similar algorithms are all being trained independently. And as soon as we're able to sort of unify them, then we have a very, very powerful AI potentially.
I think what it means to me to unify those things is, to be honest, a little bit hazy. And if what you're going for here is, okay, I have GPT-3 that can do language. I have Copilot that can do specifically code. I have other models that can do images. It sounds like what you might be going for is, okay, maybe we combine these all into some like kind of master thing that is more generally capable, something of that sort, I imagine.
Yeah, well, I think, there's tools out there, for example. I mean, like I use Terraform quite frequently, which is, you may or may not know, but is a tool to spin up your own infrastructure. What if you give the AI its ability to go and spin up its own infrastructure and create an extension of itself? Like, all of these tools for automation are out there. They're out there available on the internet to learn. And if you have an algorithm that can learn from the internet, then depending on what it figures out it wants to teach itself, it can, because it's all out there. So, I mean, I think you're right to say that it's a long way away, because I think we are still quite a long way away. I'm just wondering if that becomes very, very short, very, very quickly, if you know what I mean. Like, all of a sudden, it then becomes much more powerful.
I think that's the fear generally, isn't it? It's like, yes, this might not be an immediate threat, but where is this going,
Mm-hmm. Yeah. So I guess the first thing I'll say is, if you are worried about your AI system having access to networks where it can teach itself things, don't give it access to those things, ideally,
Locking up a naughty child.
Yes. The second thing I'll say is, I think you're right that this is really the general worry, right? So a lot of people in the AI alignment community, I think, consider this exact question. So right now, it might seem like we are really far away from some kind of super powerful AI takeoff scenario. And in his work Superintelligence, right, a couple of years back, Nick Bostrom described precisely this, that it might not seem like it, but then at some point we might find ourselves crossing a threshold where AI systems become superhuman in their intelligence capabilities. And this might happen slowly, and we might have some time to figure things out, or it might happen very, very quickly, and we might not know it until we are already over that threshold. And that is why a lot of folks right now are very concerned about this sort of thing. We have a lot of people in the AI alignment community who are working on problems like inner alignment, like some of the things we're talking about, to better understand what happens when you have more advanced AI systems. How can we make them safer and all of that? So I guess what I'll say there is, I am very glad that we have places like Mary and OpenAI and people working on safety and all of that. And that I hope that if this kind of takeoff scenario does come about, that it is much, much later rather than sooner.
Yeah, I think the threshold was a much more eloquent way of putting it than I'd managed.
I fortunately have Bostrom to credit for that and not myself.
Anyway, bringing it back then. So, what are the current practical applications of this? Because I know that you'd spent a fair amount of time at Amazon. I'm presuming that some of the recommendation stuff you were seeing there created some of this interest. Would I be right in that assumption?
Yeah. So I guess recommendations has been a somewhat separate interest. I guess what I will say about recommendation algorithms generally is it seems to me like an industry, there's kind of a pretty big gap between the recommendation systems that you see in academia and the ones that actually get used in industry. Industry ones, because of the engineering challenges, can very quickly become a Frankenstein and a little bit difficult to manage from the engineering perspective, which makes it a little bit difficult to introduce scientific complexity into that. Whereas on the other hand, everybody in the recommender systems community and all the conferences is like, okay, what's the latest cool neural network model we can use for this? Let me use like dual head attention models or like BERT or something like that, something crazy. So that being said, I think that, recommendation systems, at least from the scientific perspective, seem a little bit less exciting than I was anticipating. What that actually did get me interested in was some of the ways in which recommendation systems kind of impact us, which is a related but somewhat different conversation, because I think that what a lot of the conversation around recommendation systems have been focused on recently is that kind of unexpected behavior. Maybe not totally unexpected, but the fact that they find ways to draw us in and generate user engagement in ways that might not be so good for people, especially when you think about them on social media platforms. If you want to jump over into that conversation, I'm more than happy to. But just to clarify, that is something a little bit separate as far as interest goes.
Sure. Well, I mean, it depends. Have we covered what we needed to cover on the threat of AI?
Yeah, I think we have. So TLDR, I don't think it's a major threat right now. Don't be too worried if you're listening to this. We are definitely a pretty far away from, your toasters starting a rebellion against you. Although just in case, you might want to say thank you to your toasters every time you use them. I personally do that.
It's never going to be the toaster. It's never going to be the toaster.
That's fair, but you never know, right? Maybe something else enables the toaster and it's really mad at you for some reason. Yeah. I wouldn't be too worried right now. If you are thinking about this, there's a great piece, maybe we can link it in the show notes, called Philosophers on GPT-3. It has pieces from Ed Zimmerman, who I think is a really cool AI ethics person, from David Chalmers, others kind of reflecting on what they see as the capabilities and limitations of GPT-3. Some of it's from like a philosophy of mind perspective. But perhaps if you find yourself a little bit anxious, some of that could be soothing to you. I know it was to me.
Are you getting the impression that I'm anxious about AI?
Oh, I meant the general you as the listener, but yes, Chris. Also, if you're anxious, this might be some good therapy.
I was wondering if that was what I was giving off. Just a general anxious vibe about AI. It depends what time of day you catch me, really.
That's fair. That's fair.
Well, Musk had those things to say about AI. He had a few frightening remarks around it, and you think he's in tune with some of the latest tech, and he's saying he's worried. So what is that going to do for the rest of the world? Do you know?
Oh yeah, I mean, there's definitely reason to be worried if we're not careful, right? And I think that's really the key thing to focus on. So even today, when we are building like self-driving systems, also I will call out Musk a little bit on this because he seems to not have been super careful with Tesla. But, if you don't ensure proper safety in things, even like self-driving systems today, if you don't market them properly so people actually understand what they can do and can't do, if you, like Tesla, call your systems full self-driving when they're actually not anything remotely close to that, then you end up in situations where people end up in crashes and lose their lives. And that's already pretty bad. And you can't figure out, because of our legal system, how to attribute responsibility for that. And so there's a whole bunch of hairy rabbit holes we go into. And that's just with today's AI technology. And I think the problem there, though, is the humans not thinking about the safety of these systems and how to construct good kind of AI human interfaces and handoffs and things like that to mitigate the downside risks of what happens when an AI system goes wrong. I think that really the best way forward here is to maintain I think optimism about technology is good. That's what pushes us forward, but it needs to be measured. I think that we need to go forward with the respect of, okay, we'd like to continue building things like AI technologies that plausibly, I think, are going to be really great for humanity in the future. We should expect that things are going to go wrong, that they're going to have unexpected behavior. We should anticipate that and think about in advance, okay, how could this potentially go wrong, and start building things in place to help us mitigate those risks. You can even see this today. This is somewhat unrelated as far as topic goes, but there's a really big story that the New York Times broke back in 2020. And this was about what at the time was thought to be the first basically false arrest of a man due to a facial recognition misidentification. So this man, Robert Williams in Detroit, was misidentified as a shoplifter because of a facial recognition algorithm, and eventually got detained and arrested, despite the fact that he had never actually been to the store in question. Now, what I think was really striking about this story is not the fact that the facial recognition algorithm got it wrong. I expect that to occur at times. And I think that the AI bias question there is really important. And so, yes, we should be training these algorithms with more representative data sets. We should be implementing things like model monitoring and understanding how they perform in real time and trying to improve them as they are being deployed. But I think what's even worse about the situation is the way the whole handoff between technology and people was handled. When the police, saw the output of the facial recognition algorithm, they did no further background checks to figure out, does Robert Williams have a criminal history? Has he done anything like this in the past? Has he even been to this area? They just included it in a 6-photo lineup that they showed not to the victim of the crime, but someone who watched the surveillance footage and showed it and sent it to the police. So they also did this months after the fact. So I think there's multiple things going on in there. The fact that the police added this to a photo lineup without any background checks, the kind of automation bias that occurred when they probably did that, the fact that they showed this to a person who was not there at the scene months after the fact, the cognitive bias that might have caused in this person. Now, it was that person who chose Robert Williams' photo out of the 6, which caused him to be arrested. But still, again, I point out, I have I think there are reasons to be skeptical about whether we should trust, that person and whether what they said about who was there at the scene is actually correct. There's a cognitive bias there that you have handed me 6 photos. There are probably reasons that you are fairly certain that any one of these people could actually have been the culprit. There's that kind of cognitive bias. But then, of course, the fact that the person wasn't actually there at the scene introduces reasons to be skeptical about this. And the reason I say this is that what was going on here was, I think, just an immense failure of the people to take into account that an algorithm was probably going to be imperfect, and to account for that by putting measures in place to mitigate that potential negative impact. And what happened was a man was wrongfully arrested, which is really a terrible outcome. Now, the AI bias component of this and the fact that he was African American is extremely important to this story. But what I think is also extremely important is just that there was no system put in place to verify the output of this algorithm. The police didn't do much due diligence on their part. And so what I think is important to take away from a story like this is that in the future, as these technologies get more powerful and their failure modes are potentially even worse than this, we need to think about that in advance. We need to expect that and have systems in place. Those police probably should have done some additional background checks. We need to be really careful about our automation bias. The fact that an algorithm puts out somebody as the answer to, who was here that one day doesn't mean that it's necessarily correct. So we also need to be thinking about our own biases there. And, that's a little bit hard to do when we are using the AI system, at the time. So I think that considering these ideas before we start using these systems and putting those structures in place before the fact is going to be immensely important as we go into the future. And to some of your potential anxieties, Chris, about takeoff scenarios, about all of that, I do hope that doing things like this is going to help us into the future, mitigate those potential negative impacts.
Yeah, but I think this is a problem. I mean, obviously, it's particularly bad in this scenario where the police are actually picking up on the bias and not actually doing those additional checks. But it's a problem that's been happening for decades anyway to do with automation. I mean, there's plenty of stories of people using their satellite navigation to the letter and driving into fields. There's the age-old internet sort of legend, which I'm not sure how true it really is, about the man who bought a Winnebago, set it onto cruise control, made himself a cup of tea, and totaled the Winnebago. That is a bit of an internet legend, by the way. So it does crop up in different names and different people and different genders. But the thing is there, people make an assumption of what that technology is. I.e. the satellite navigation or the cruise control or actual facial recognition. I mean, facial recognition is a bit crap still. You do have to have all these other checks and balances around it, because otherwise you are going to make horrendous mistakes. I think it's really important that you raise that, though, on the point of the police.
Exactly. And, that's also, I think, part of the motivation for the book that I've been writing, just that I think that there's lots of ways in which we have mistaken notions about technology. Sometimes we think that it is too capable. Sometimes we might be incredibly pessimistic about it. And so I think there's really, hopefully, good service for a general audience, for people who might not be techies, who might not be following all this and already have that sense, how capable are the technologies around me? I think that can be important, not just if you're concerned about AI in particular, but just for your daily life and the use of the technologies. I'll give you kind of an example of this too. Every time, so my mom's car, now she got it pretty recently. It's a Volvo, and it's got a speech identification system. And that speech recognition can basically, I think this exists in a lot of cars today. You can be it's like the Hey Siri kind of thing, right? And you can be call this person on my contact list. Hi Siri, shut up. I don't want you here. Sorry, that was Siri on my actual computer.
I have all of mine turned off. It's interesting. That's probably just emphasizing my anxiety that I have all of the voice assistants turned off.
That's a great idea that you did. I probably should have done the same. That being said, she'll often be in the car and be call my dad. And this system never fails to impress us with a number of different ways that it can get what you said entirely wrong. Sometimes it is calling someone whose name sounds nothing similar to my dad's. Sometimes it's like, oh, you want to go to this place in like Tempe, Arizona, 100 miles away from you. It never really, fails to surprise us with the ways in which you can get things wrong. And the fact that she kind of continues to try it feels, a little bit naive to me, although, I'm glad that she maintains hope that this car might someday cease to be completely trash and actually, do what she says she wants it to do.
Do you think that that's a learning algorithm in there then or not? Is it getting better?
Unfortunately, I think that what we have is not like a smart car, but, a moderately intelligent car, if we can even call it that. And so I think that what's, going on there, right, is sometimes people have too much trust that a system is going to work. And what I see there in my mom is, kind of a holding out of that hope. And I don't want to be like the pessimistic guy of like, give up all hope, just like take a deep breath and like give up on your technology, but be aware that it is probably going to fail in all sorts of ways. And you maybe can't use it for everything you think you want to use it for. So like, yeah, definitely do not pour yourself a cup of coffee while your car is on cruise control. Also, a lot of people have been taking videos of like Tesla's full self-driving. Some of them have been ending up in crashes, but they've been like making TikToks or other videos of them like in the car with their hands off the wheel, in the back seat, nobody in the driver's seat. Like, don't do that. The technology's not there yet. We are not at a point where self-driving can actually even like navigate a highway that safely yet. Like Waymo, and Tesla are still testing their vehicles on miles and miles of road. So be careful, spend a little bit of time getting to know the technology you use. Think about what its capabilities are. But also what I think is interesting here is there's an introspective sense to that. So I think both the technology itself and the marketing can sometimes impact the way that we think about things, and that affects what we think the capabilities of technology are. If I own a Tesla product that markets itself as full self-driving, well, that's going to impact the way I view my product, the way that I think about its place in the world, and so might impact the way that I use the product. And I think that's something to be very careful about. And it would be great if more people kind of engage in that kind of self-reflection of how do I relate to the technologies I use? What do I think about them? What do I think that their capabilities are? And how do those technologies themselves and the marketing around them and the way we speak about them, how does that affect my relationship with that technology and the ways I'm willing to use it? So if anyone listening to this wants some homework, I highly encourage you to engage in that self-reflection.
Mm-hmm. Yeah, I think it's important. It's interesting that you mention on the self-driving car side of things because, well, and also the Volvo side of things. So, the technology is out there. To build these things, to build something that it does have the potential to be self-driving or self-learning. But you do have a lot of organizations that are doing that. For example, the difference between Tesla and Volvo in this scenario, I imagine that Tesla are probably putting an awful lot more software engineering into actually building a self-driving car than what Volvo necessarily are. And obviously, I'll happily correct that if Volvo want to correct me. But I would imagine a basic voice assistant, there's a different level of technology that's going into the creation of that than there is going into the self-driving car side of things. How difficult is it from your perspective to take something that already exists as an algorithm and to use it, to apply it in this purpose? How easy would it be for Volvo, for example, to decide that they were going to build entirely autonomous self-driving cars? And we know we've got there is some clever safety features in Volvo where it does like the auto stop and stuff like that with the trucks, because we all saw Jean-Claude Van Damme advertising that for us. But to get them to being full self-autonomous, is the stuff that I can go and find on the internet to go and get myself started if I want to decide I want to go and turn my car into being self-driving?
Well, for a couple things, I guess I would personally think it's a little bit silly for Volvo to go after that. It would probably be a big investment of money and the return on it might not be that great. Are there ways you can get started with self-driving yourself? There are some things on the internet and certain guides where you can maybe take train a little bit of an algorithm to like identify things on the road. I know that a while ago, Udacity did this whole like self-driving nanodegree thing. I don't know if I'll actually recommend that, but it's something you can try if you're interested. There are probably lots of free things on the internet where you can kind of learn, okay, how do I make a vision algorithm that like detects things on the road? If you actually want to make your own car self-driving, do not try this at home. This is an incredibly complicated problem. Google, Uber, Lyft have poured hundreds and hundreds and millions of dollars into this and have not yet solved this. And I think it's really telling the fact that both Uber and Lyft have recently sold their self-driving units. My friend used to work at Uber ATG, their autonomous driving group, which got sold over to Aurora, another self-driving company. Or I guess not sold, but basically sent over to Aurora. And Uber kind of now has a controlling stake in Aurora. But that being said, it's really telling that both of these companies, which are pretty massive, decided to give up on their internal self-driving efforts. Maybe not entirely, but really the vast majority of it, they realized probably were just bleeding money. And the benefit they were getting from that isn't worth it. And I think what's interesting here is that self-driving is a really, really hard generalization problem in a way that almost nothing else is. So just to go back to some basic concepts here, right? One of the things we speak often about in machine learning, in case anyone isn't familiar, is this idea of generalization. And I've hinted at this with this whole stuff about like generally capable agents from DeepMind. The idea being that we want to develop algorithms that generalize to unseen data. Can they not just memorize the mappings between, this image is a dog, this image is a cat, but when I give it an entirely new image it's never seen before, it knows whether it's a dog or a cat with pretty high accuracy. That's what we call generalization. In the same way, for a car, it needs to be able to generalize into absolutely novel situations that not only has it not seen before, but almost nobody probably has seen before. You can imagine that nearly every situation at a traffic stop is this complex multi-agent, multi-actor scenario that might just be entirely novel to the entire world. And so there is no way that we could train a self-driving car enough to understand everything it is potentially going to see in the future. And the road is really just an incredibly unpredictable place. That is part of what makes the self-driving problem so insanely difficult, and is probably part of the fact that we are not really there yet. So I think we are still, the industry seems to think that we are like many, many years away from reaching, even something that is fairly competent on like a city road. There are even folks, like there's a company I heard about recently called Ghost Locomotion that is trying to solve just a subset of the self-driving problem. So specifically self-driving just on highways, which is somewhat easier than in cities, since those are going to be less predictable. And they're trying to build hardware that you can hook up to your car and kind of make it self-driving. But even that in and of itself is a really, really difficult problem. Again, you've got this whole multi-actor scenario. You've got a whole bunch of cars around you. You've got to handle things like, okay, if there is a biker on the road and then another car I could potentially crash into if I avoid the biker, what do I have to do there? There's a whole bunch of people who are worried about the ethical problems with self-driving cars. And there's been a lot of talk about like the trolley problem, except it's a self-driving car instead of a trolley. Yeah, and I think some people have taken it to the point where it's like, well, almost every decision that a self-driving car makes has some moral salience. If I move like 5 inches farther away from this bicyclist, or if I move 5 inches closer, that has some impact on the bicyclist's safety versus the safety of the person inside the car. So there's a lot of conversations to be had about that, even if that's not technical. But I do think that the technical problem is hard enough that there is still plenty of time to, go about solving it. It's a pretty long way away. I'm glad that there's people working on it, because I do think that, if we get it right, it definitely does have the potential to save lots of lives. But it is an incredibly, incredibly difficult problem. So maybe like do not try this at home. Do not try to create your own hardware and just like let your car loose on the road. But there are lots of places where you can learn about it and what like a simple self-driving system might look like. Just be aware that it's going to be much, much harder than just training like a neural network to figure out, where are the stop signs, where are the people on the road. Even Uber's system that failed in Arizona recently had trouble with that, there was like a person walking across the road that this car crashed into, and it misclassified her a whole bunch of times and finally classified her as a person right as it was about to crash into her. So the fact that, a company like Uber had some difficulty with this, even though it was a couple of years ago, I think means that, trying this at home is going to be also a little bit more difficult.
Little while to go then, a little bit.
Just a little.
There's a lot of information to process though on a self-driving car though. I mean, it makes me wonder, would you actually classify there being a difference between artificial intelligence and machine learning in the sense that the car that's handling all of that information needs to have a very good way of processing all of the information that's coming at it, making decisions, but there is also all of the ethical side that goes into that. For example, the trolley problem, as you mentioned. And for people looking for a good explanation of the trolley problem, you can find it on the internet or in The Good Place, which was a great...
Love that show.
Had a great explanation of the trolley problem. But I'm wondering, do you class there as being differences between machine learning and AI, or a combination of the two together?
I'm glad you asked that question, because I think that is one of the biggest misconceptions from people who don't spend all of their time thinking about this stuff like I do. And one thing you might have noticed in this conversation is I've been very careful not to refer to an artificial intelligence or say anything like that, but I've often referred to AI systems. And that is because for many AI researchers, the word artificial intelligence is not a noun referring to the system itself. So there's been many researchers. We actually have an article about this on Skynet Today that one of our editors wrote. Perhaps we can put this in the show notes as well. That is literally called, "Please stop saying an AI." This will really annoy AI researchers to absolutely no end, because when we refer to artificial intelligence, we really refer to this field of study. AI is just what it is, a field of research that is dedicated to creating systems, agents that are generally capable, that have some sort of intelligence, that are capable of solving problems and tasks and demonstrating something that seems like intelligence. So when I say AI, I usually refer to the field of study. And when I say AI systems, I just mean intelligence systems that implement something like machine learning that are capable of doing things that seem intelligent. And so machine learning is specifically, right, just a specific way of achieving what we would think of as an AI system. So I think that's kind of the answer I would have to your question. Now, are there ways of, I think what's also part of your question maybe is, are there ways of achieving AI that are not machine learning or that go beyond machine learning and incorporate other things like ethics? And so what I would say there is this: there are other approaches to AI systems. And before machine learning became a huge thing, I think, and I'm not an expert in this area at all, but I'm aware that there are approaches from kind of symbolic systems and symbolic methods. And I think what these attempt to do is really specify a whole bunch of things in the environment. So, if I'm a car, then I might have pedestrians, I might have signs, things like that. And all of these things are taken as more or less kind of mathematical objects almost. And they're treated as symbols that can then be used to generate inferences. And so those symbols connect together in certain ways. And so in a sense, I am building a bottom-up picture of reality instead of machine learning, which goes from this top-down picture of reality, which is you already know what this whole picture is. Now learn the low-level equations that help you figure out what it is. So there is that kind of difference. Now, to the other part of the question, okay, what about systems that seem to go a little bit beyond machine learning and incorporating things like ethics? I think we're far away from a self-driving car that implements any notion of ethics yet. But if we did have something like that, one that had some idea of ethics and ethical principles, what would the approach to that look like? I can't say I have a really good answer for us there, because I'm not totally sure I know exactly what that looks like. But what I will say is that, at present, what an AI system is really just a machine learning algorithm that has been incorporated into some software to solve a specific problem. And so now you have a system that is capable of solving a particular task. Hope that kind of clarifies the terminology there.
Yeah, I think that does clear it up a bit. So in terms of what we haven't covered, because we've covered an awful lot.
We have indeed.
When we brought it back down to sort of that recommendation side of things, I think simple recommendations, simple voice assistant related things that you get through Google Home or Siri or Amazon. That's where people are probably most experiencing those things right now. I would assume, things that are prioritized for you on your Facebook news feed or something along those sort of lines. Those two things, they do still feel quite divorced from some of the more extreme machine learning or AI systems that we've been talking about. See how I'm learning as we talk?
Love it.
How do you bridge that gap for people? Because obviously this is the sort of thing we're going to expect to find in the book. Like how do I take what I see and maybe understand the implications of me getting a recommendation or an advert or something based on a conversation I was having, or a chat that I was having online. How do I understand the implications of that for me and how that factors into all of this other stuff?
That's a great question, and it's a good thing I talk about this specifically in the book as well, actually. So I do try to give a sense of both some of the short-term and long-term concerns. So, it's not all about super advanced technologies like GPT-3 and what we're talking about. I'm glad we did, kind of go into a long discussion on those. But definitely the content of the book extends well beyond that into technologies like recommendation systems that do affect us in our everyday lives. So if you are interested in reading the book, you will find plenty of material on that. But first, just in terms of the overlaps, I think that there's an overlap just in the general way that we think about safety and deployment, right? So for a system like GPT-3 and a system like a self-driving car, the framework that I think about with these things is, okay, these are going to affect people at the end of the day. They could be good for people. They could potentially have failure modes that are bad for people. How do we construct systems, people and AI systems, so that we can make these as safe as possible and achieve their intended good effects as well as possible? A recommendation system is very similar. It is going to affect people at the end of the day, the users of Facebook, of YouTube, of Amazon, and it could have some good effects. It could show them content that they really like or were happy to see. Or, as Mozilla found in a recent study on YouTube, it could show them a whole bunch of videos that they absolutely regret watching and wish they had never come across in their entire lives.
Which is a great article if you want to go away and look that up. There is a great insight from Mozilla about the regret. I think regret was how they phrased it, wasn't it?
Mm-hmm. It was exactly
66% regret or something along the line.
Something of that sort, exactly. And what's happening there, right, is that you are now the user on the other end of this recommendation system, and there are folks who are building out that recommendation system in order to capture your interest, to make you spend more time on Facebook, on YouTube. Their metrics are something like watch time, and that doesn't sound awful on a first blush. Like, yeah, of course, Amazon wants me to buy more things. Like Facebook wants me to spend more time on the website. Maybe you expect that a little bit at this point. I think that there's been a lot of conversation around this stuff, and so it's maybe not a huge surprise to anyone.
Well, it's the extension of the time spent on site metric that we've been measuring since the beginning of the internet. And from my time at Amazon, working for instant video almost a decade ago now, the main thing that we were talking about then was minutes viewed, increase the number of minutes viewed. And for me, even a decade ago, with all of the advancements that have happened in between, that felt a little bit uncomfortable for me ethically, because you're trying to keep people in front of the television that we know is a bad thing, really.
Yeah, exactly. So, it's worth being aware that these systems are trying to kind of affect you in lots of ways. And so, there's ways you can get past that. You can there's Chrome extensions and things like that where you can kind of just blank out your Facebook newsfeed or the recommendation algorithm or things like that. So that can be very helpful. But I think also just being aware of it is really helpful, not just as you navigate the internet, but when we talked about, GPT-3 delivering people disinformation, there was another study that found that simple awareness of the fact that you might be being fed disinformation, being recommended certain things, can actually help you better distinguish between true information and false information. Now, where I wish we could go with recommendation systems, though, is there's been a lot of great activism around this recently. So I don't know if you two watched it, but The Social Dilemma, which came out on Netflix last year, featured Tristan Harris from the Center of Humane Technology and a lot of other folks who spoke out about the potential dangers of recommendation systems. Now, I personally found the picture they painted incredibly bleak. They kind of told the fictional story of this boy who was trying to escape his phone and Facebook and really ultimately totally failed to do it. And there were these guys who were supposed to be like the recommendation algorithm or something who were sitting inside this control center and were like, ha, we got him, like it was a video game.
Yeah, I turned it off after I see that. If I see a human representation of algorithms, I'm afraid I'm out.
Yeah, I'm glad it came out because I think that it really turned a lot of people's eyes to the problem, and it is very incredibly important. What I think, though, is maybe more salient, and I guess like an analogy I've come up with this is, the reason that I found issue with recommendation algorithms generally, not to say that they're going to disappear, is just that they appeal to these kind of first order desires we have, right? So, for example, most of the time, I would be very happy to indulge in ice cream. I'm like a huge ice cream guy. But that is not consistent with like my second order desires. I don't want to want ice cream all the time. Or with my general volition, like, I want to live a healthy life. So imagine that every time I pass by an ice cream shop, I have this kind of demonstrated volition. Like I look inside the ice cream shop and there's all these great flavors and I take a second to stare at them before I move on. And maybe there's a 5% chance, say I have some self-control here, that I lose that self-control and, go in and get that ice cream. Now, what a recommendation system is doing is saying, hey, every time you come by and look at this ice cream parlor, I am going to come up with the absolute perfect flavor or sundae that I am going to show to you in the window. And now, instead of being 5% more likely to lose your self-control and eat some ice cream, you are 10, maybe 15% more likely. Now, that still doesn't sound that awful, but over the course of my lifetime, now, of course, probabilities don't work this way, but an expectation that means that I'm eating 2 to 3 times as much unplanned ice cream as I was before. That means I'm a little less healthy. I feel a little bit worse about my decision making and about myself as a person. And this is, in some sense, the way I've started to generally think about recommendation systems and why I still have some moral qualms about them. Now, what does this mean you can do as a user? Well, just being aware of the fact of recommendation systems, I think is pretty useful. If you want to try to start limiting your time on things like social media and being more aware of that and the relationship you have with technology, I think that's great. I think this is also a really good time. I took a lot of time this pandemic for some self-reflection about the ways that I relate to technology and the ways that it affects me. And recommendation systems are a massive, massive part of that. But, I think this and the advanced technologies all kind of fall under this umbrella of, on the user side, you're being affected by some technology. And there are people on the other end who are building out that technology. And that I think that you, even if you're not a techie, deserve a say in how some of that technology is built. And so I think that just knowing about it and having a good sense of how it affects you empowers you to assert your voice in that conversation by whatever means you can, whether that is writing to policymakers about it or sending a message to someone who works at the company. Having a sense of how these things work and how they affect you really enables you to be a part of that conversation and say something that is a little bit more meaningful. On the other end, there are those of us technologists who are building out those systems. And what I think is most important is that kind of human-centered design perspective. I think we need to be more proactive about engaging those people on the other end who are going to be using our technologies at the end of the day. And I think that bringing them into the conversation about how we want to build these technologies, how we want to use them, how we want to govern them is going to be incredibly, incredibly important. I think that we are still, far away from the sense in which we have really acceptable use guidelines for things like recommendation systems. We are still in a situation where AI systems are used for all sorts of things like hiring. The companies like HireVue that build these systems don't have to disclose how they work. And so job seekers don't have a good sense of, what is this machine learning algorithm that is scanning my video to understand what I'm doing. I know that the EU has proposed this draft Artificial Intelligence Act, which tries to get at recommendation systems and the ways that they can impact people. But the legal terminology is incredibly difficult to work out, and people have pointed all sorts of problems and loopholes in that. I do think that really the best way forward is just an ongoing conversation and bringing more and more people who are being affected by these technologies who aren't necessarily technologists and policymakers already, helping them understand how these technologies affect them and really advocating for those voices in the conversation. So I think that's kind of the main thing I want to say there and the main overlap between all of this.
I think if unplanned ice cream doesn't end up becoming a subtitle or an article, I would be very disappointed. I mean, maybe that's how they cut through the legal jargon. I think it's really interesting that you pulled that one up, because I think there's a couple of things in recommendations. You know, in the unplanned ice cream scenario, that's almost a sort of dopamine target, isn't it? It's trying to get you on the thing that will go, yeah, I could have some ice cream, which again, I'm equally vulnerable to. I think the other thing is, like, sometimes with recommendations, you get stuck in a bubble, and we've known a whole load around, you know, the problem with bubbles and social media and all of that sort of stuff, where you can get totally and utterly trapped. In the case of whether you have right wing or left wing politics, but also the same thing happens in movies as well. Like if you're on Netflix, you can miss out on the huge long tail of content because you're going to be recommended the stuff that Netflix thinks you're most likely to click on. Unfortunately, that's not strictly true, because, you know, just because you've watched, you know, a couple of different titles doesn't mean that actually you wouldn't have watched a whole load of other things. I think that's a general problem with recommendations. I can totally see it if it's trying to just sell you on the next possibility of ice cream. That is a small dopamine trigger. But the stuff that's trying to keep you entertained or keep you looking at stuff or expand your thoughts, I think it's missing out on that part. And I'm not sure if that's still the same, whether they're still trying to go after that sort of dopamine fix or whether it's something else. Like, there feels like there's different targets to those same recommendations.
That's a great point that you raised there, and something that I think we should definitely touch on. So I think there's that question of trying versus what actually occurs. And this speaks to our unintended behavior conversation a little bit earlier. So I think that, yes, it is very true that you go onto YouTube, and there have been numerous studies done on this, that, you know, you go down one rabbit hole of content and YouTube is going to feed you potentially more and more extreme versions of that content. And, you know, that really puts you into this rabbit hole. You are viewing the world through a single tube. You are not seeing other ideas, other visions of the world. And, you know, I think for like the user who wants to escape that, you have to be a lot more cognizant about the kind of social media video diet that you are feeding yourself and really try to break out of that rabbit hole. What I think is going on there is this, and I think this is the way that it's been described a lot. These algorithms are really, right, designed to get you to spend more time on site, to click more things, to watch more things, to spend more time watching videos. That is, it seems, not that I've worked at YouTube, but it seems like that's kind of all that they are specifying for the algorithm to do. Now, how the algorithm does that is a totally different matter. And this actually speaks a little bit to the inner optimization stuff I was talking about earlier. Not that there's a full optimizer going on in there, but when you specify an objective, something for your algorithm to do, it can do that however it wants. Now, Tristan Harris has made the claim that the way recommendation algorithms do this on social media, on YouTube, is by making the problem a little bit easier for themselves. They want users to click more things, to spend more time on site, to watch more videos. So how can we do that? Well, why don't we manipulate the user into being as predictable as possible by having a single-minded political view and then feeding them everything that corresponds with this view, because I know that once my user is very predictable, then I can just feed it all of the stuff that I know it's going to eat up. And that makes solving my problem a lot easier. Now, I think this does ascribe a lot of cognitive ability to a recommendation algorithm that I don't think it necessarily has right now. But there are reasons to think that things like recommendation algorithms might be solving problems like maximize watch time, like maximize click-through rate, in ways that we don't want them to be solving those problems. And often, especially with very complicated machine learning algorithms, it is hard to know why they are doing specific things, why they have specific outputs. What are the reasons that they have for doing certain things, and what are the ways in which they are solving your problem?
Well, I like the concept that they are trying to simplify the landscape to make it easier for themselves. And I can understand from an engineering perspective that is a thing that you would try and do. I agree with you as well, though. I don't necessarily think that the recommendations algorithms are intelligent enough to be able to do that essentially on their own. I think that we are missing something, though, because of these recommendations algorithms. I think it's a real shame, to your point, that they are a bit more of a black box. It would be great if they're more opened up and if people have more input into them, because we are missing out on that sort of creator side of things. There is an increasing trend, I suppose, between YouTube, other creator platforms, social media platforms, where it is becoming more pay to play. Like, you've actually got to contribute some cash to advertise yourself and get yourself up there, rather than being on merit. Things don't become a meritocracy because it's all focused around, well, there is a cognitive bias. If 1 million people have watched this video, then I should also watch this video, that sort of thing, rather than exploring and finding the new stuff. And so I think it is causing problems for sort of creativity in the world, because people can't find content that gets created. It's a very difficult way to sort of get started. So I think it has other wider ranging impacts as well.
Yeah, no, absolutely. I think that on the creator side, things are really difficult, just kind of getting started on YouTube right now, unless you get really lucky and the algorithm kind of helps you. I think that's why people have started forming careers out of things like search engine optimization, right? How do you get your page results ranked as highly as possible on Google? In the same way, people think about how to game the algorithm in terms of getting their content valued more highly by LinkedIn's algorithm, by YouTube's algorithm. And so now it seems the job of a creator, someone putting content out there, is not just the content itself, but okay, how do I play around with these algorithms to have them better rank my content? To what you said about understanding the algorithm on this side, I don't know if we'll ever be in a space where, the creators are fully going to understand YouTube's algorithm and everything about it. Like, that's proprietary stuff and YouTube isn't going to do it. But that being said, I do think that there's an argument for interpretability and more knowledge about these algorithms, just in terms of understanding how they could potentially affect people. And I think in the United States, Congress has been calling for this recently. They've talked to the big tech giants and they're like, hey, we don't understand how your algorithms push content out there, and they could potentially have really bad consequences. And so you need to be a little bit more transparent. Now, I don't know if they'll ever be fully transparent, but one idea that came up recently, I think one of the big people around it was like Oriana, who heads the Allen Institute for Artificial Intelligence out in Seattle, was the idea of auditing algorithms. So the idea of a third-party audit for an algorithm is not that the company has to expose all of the internals of its algorithm out to the public, because Google's never going to do that with their search algorithm. YouTube's never going to do that with their ranking algorithm. But if you can expose something like an API to use the algorithm to give it inputs and get outputs, then folks could plausibly test the algorithm with certain inputs, not knowing how it works, to better understand how it makes decisions, and at the very least get some kind of intuitive sense of what it's doing there. And I think that auditing, if it does happen, could be a really good way of managing that trade-off between, okay, this company wants to keep its proprietary technology under wraps, but other folks really want to understand how it works and whether it has particular consequences for safety for the users of that website. So I do wonder about that being a potential solution and path forward. It doesn't sound like anybody's doing that on a massive scale yet. But.
No, I mean, I think what you mentioned the Mozilla article earlier on, and I think having some sort of ethical dashboard for an algorithm would be really interesting. It'd be really insightful, because clearly, if you're able to do that sort of insight and discover what Mozilla discovered, that actually most of the videos recommended on YouTube are regrettable, then, well, that's not a good thing, and we should do something to fix it. I think the problem with some of the Congress stuff, I think it's great that they're going after it, but you only have to look at the Senate hearing with Zuckerberg, or I think there's been a couple of them now. It's embarrassing, frankly, to see members of Congress trying to actually hold someone like Zuckerberg to account, because they don't have the capability. And we do definitely need some form of ethical transparency around it. I would totally agree with it. It's a general problem across the world. I mean, I'm not sure what the current state is, but a couple of years ago, I looked at the members of Congress in the United States and the European Parliament and the British Parliament, there was only one person who had a computer science degree, and he is a member of the UK Parliament, a man called David Davis, who got his degree in 1979 when punch cards were all the rage. So he can't necessarily even be if you've got one person across a few thousand representatives. What hope have we got of actually holding tech giants to some sort of account? Because I think that's the thing. It starts as an engineering challenge. We want to be able to display better content, and in fact, that's actually how it happened. I believe with Amazon with the initial recommendation service was we will pitch this against the editors who are choosing which books we want to display on the homepage. They pitch the algorithm versus the editors, and the algorithm sold more books, so that wins. The editorial team gets sacked, and that's a good engineering aspiration. But it's if it continues down the road, so that 20 years later we're in that situation where the percentage of regrettable videos is extraordinarily high, that can't be a good thing for the industry or the world.
Yeah, not at all. And I guess one thing that I really hope, and I think it seems to be starting to occur a little bit, I guess specifically with Facebook too, is just the idea of the market value of a company. Because I think what's going to happen, right, is that companies are always going to be driven by things like their bottom line, right? Whether that's Facebook or Google or their latest startup. That's going to be a very important factor of that company. And so as important as ethics might sound, or they might claim ethics are, really that's going to go a little bit by the wayside when it comes to the bottom line. I've heard about self-driving companies that ditched their entire safety teams because, they were struggling with that bottom line, which is a huge, huge red flag, but kind of just goes to show, the company's got to survive somehow. Now, I don't think that any of the tech giants are struggling to survive at all. And, I do think that when you think about it, if you look at the profits they're making, the incremental impact of it, I don't know how large it is. I think the fact that they're able to fund, such blue sky research initiatives and things like that, there is some kind of social benefit to be argued about the ability of them to do that and the fact that they're so big. That being said, I think on the ethical side, it would be interesting to see if the market value of a company could be tied to its ethical status among people as well in some way. And I think that it seems like over the past year, more and more investors, at least the young investors, have started to look at companies that seem to have good missions, like green technology and all of that. And so there's a sense in which people are starting to pay more attention to that when deciding whether to buy shares of a company. And so I don't know if it will ever be that way with the tech giants, but if we do trend towards that, I could imagine a greater incentivization towards those kinds of things. I think really, though, it is just it bottoms out at a real game of incentives. How do you incentivize a large company that is focused on its product to think about the ethical consequences and put time and effort and resources towards really making transparent some of the ethical implications of that technology? And maybe if they don't do it, how do you create a sort of external auditing system where they can keep that proprietary technology under wraps? And then the folks who really want to do that work can do it and kind of make that more publicly available. And I guess there's probably different answers to this. And I don't know if there are, even fully clear answers to all of those questions right now. But I think those are really important ones to think about. And I do hope that, over the course of the next few years, the next decade, we get a lot closer to actually operationalizing some of these hopes.
Yeah, well, I think it would be, it's definitely a good aspiration to try and have some sort of ethical value placed on the total value of a company. So I think that's probably a good note to end on, really. Have we covered it all?
I think we've got everything.
All right. Well, thank you, Daniel. Thank you for joining us. It's been a particularly insightful conversation that I think I'm going to have to go back and listen to as well to try and make sure I've taken it all in.
It's all a blur.
So thanks for your time.
Yeah, it's been a pleasure. Thank you both.